Afternoon to all. As our second unit is going on, linear data structure using sequential organization. In previous session, we have studied concept of array. What is the array? How to declare the array? What is the uses of array? Characteristics of array. So in today's session, we are going to see the characteristics of array, advantages of array, disadvantages of array, applications of array, and some matrix operation. Coding part I will explain you later. So we have completed 2D matrix. Yes, in last session we have completed row measure representation, column measure representation. Okay, this is very important topic for unit number 2. Question will be asked for two-dimensional address calculation. यालाच address calculation सुद्धा म्हणतात. याला रो मेजर रिप्रेझेंटेशन पण म्हणतात आणि याला 2D address calculation सुद्धा म्हणतात. Characteristics of array. As we know, the array is a finite order collection. Okay, it contains a homogeneous data element, means same type of element, either integer or character. So this is one of the characteristics of array. Array is a finite order collection of homogeneous data element. You can note down the point. Characteristics of array. Array is a finite order collection of homogeneous data element. In array, successive elements of list are stored at fixed distance apart. In this array, sequentially we can store the number of elements in the array with fixed format. Means suppose you have declared the array A of 10. Means you can store the element in sequential manner. But if you declare the size of the array A of 10, then you can store only 10 elements in that particular array. So that's why it is a fixed distance apart. Third one, array is defined as a set of pairs. Okay, we have already studied array contains the two attributes, that is the index and value. So array is defined as a set of pair, and this set of pair means index and value. Okay, index means location, not value. Index means location in the array where actual value is stored. Array, fourth one, array allow random access to any element. Array allow random access to any element. In array, we can directly access the particular element from the array with the help of index. इंडेक्स चा वापर करून आपण त्या array मधला कोणताही एलिमेंट घेऊ शकतो. In array, insertion and deletion of element in between position require data movement. Fifth one, in array, insertion and deletion of element in between position require data movement. Okay, this is the one of it is the characteristics of the array. Also, it is the one of the limitations of the array. Insertion and deletion operation in the array is very difficult. It is not easy task to insert element in between the array. Yeah, in the array you can simply insert the element, but if you want to insert or delete the element in between the array, suppose 0 to 9 number at index, but if you want to delete the element which is placed on the fifth position, then it is a difficult task. You have to So yeah, it is possible. You have to, but you have to perform the data movement. Yeah, but if you want to access the element, you can randomly access the particular element with the help of the index. A of 5, you can directly access the fifth position, fifth index value. Next, array provides static allocation. Static allocation. We have already studied static data structure. Static means fixed. Fixed data structure means we cannot change the value. So same array provides the static allocation. Once you assign the memory to the array, if you define the 0 of 10, then fixed size memory is allocated to the particular array. But if suppose you have assigned 10 size to your array, but you store only 5 values in that array, but there are 10 locations, and out of 10 locations we are just using the 5, then rest of the 5 are wastage of the memory. So this is a drawback of the array. It is a characteristics static allocation, but one of the limitation or drawback of the array is that due to the static allocation or fixed allocation, due to the fixed allocation or static allocation, there can be memory wastage. इकडे memory वाया जाऊ शकते. The memory can be wasted due to the static allocation because it is fixed. Once we assign the memory, but if suppose you don't utilize that memory using the program, then it will be wastage. Okay, static allocation, which means space allocation done once during the compile time and cannot be changed at runtime. Okay. Understand one more things about the static allocation is that static allocation means compile time. Okay, when we write code in editor, at that time automatically memory is assigned to the particular variable. Okay, so that's the compile time. But when actually you run the code at that time, assigned memory cannot be changed. But in some dynamic allocation it is possible. As per our need, we can use the memory. Okay, so I will tell you about dynamic allocation in the another unit. But in this array, just try to understand static allocation means fixed allocation. Once it is allocated, then memory cannot be deallocated. And if you don't utilize the complete memory, then rest of the memory can be wastage. Okay, point note down करून ठेवा characteristics of array. Point note down करून ठेवा. Array is a finite order collection. It stores the sequential element in the fixed memory. Array defined as a set of pairs, index and value. Array allow random access or direct access. Insertion and deletion in between the position require the data movement. Require the data movement means if suppose 0 to 9 and you want to delete 5 elements, then you have to shift from 0, 1, 2, 3, 4. Then you will reach to the 5th element. And it supports the static allocation. The static allocation, there can be a wastage of memory. Advantages of array data structure. Okay, what are the advantages? We can create a advantages of array. In array, it supports the static memory. Okay, then sequentially we can store the element, fixed amount of memory, randomly we can access the data. Okay, these are the advantages of array data structure. Even I read this slide. Array permit efficient random access in constant time O of 1. O of 1 is the efficient time complexity. Array are most appropriate for storing fixed amount of data and also for high frequency of data retrieval. Okay, we can store the data, we can retrieve the data. Wherever there is a direct mapping between the element and their position with the help of index and value. With the help of the index and value, we can perform the direct mapping between the element and their position. Ordered lists such as polynomial are most efficiently handled using the array. In the polynomial operation, we can use the array to store the element of polynomial. I will in the next topic I will explain you polynomial with the help of array. So before starting the polynomial or matrix operation, we should know about the array. Array are useful to form basis for several more complex data structure such as heap, hash table. Okay, heap and hash table are the data structure which you you may not know. तुम्हाला माहित नसतील heap and hash table, but these are the data structure which we are going to study in the unit number 6. But in that, just keep in your mind, in array, in heap or hash table, we can use the array data structure. We can also, it can be used to represent strings, stack and queue. We can also store the string. If suppose you want to store your name, for example, my name is Anand. Okay, I want to store the name ANAND in the array. So I can define the array A of 10. In A of 10, I can store the alphabet or string ANAND. So you can use array for that. Okay. Also stack and queue operation, but we don't know the concept of the stack and queue right now, because in the unit number 3, we are going to study stack and queue. So we can also implement the stack operation or queue operation with the help of the array. We can implement the stack operation or queue operation with the help of array. We will see in the unit number 3. Now disadvantages of array. Okay. While explaining the characteristics, I already told you about the static memory management. That is the one of the drawback of array, because due to the static memory, there can be memory wastage. Okay, so here you can read array provides static memory management, as during the execution the size can neither be grown nor shrunk. Okay, once you assign the memory to the array with the help of static memory allocation, then during the execution you cannot change the memory. Okay, so in that memory cannot be increased or decreased. Grown and shrunk means increase and or decrease. Size can neither be grown nor shrunk. Means size can neither be increased nor decreased. Second, array is inefficient when often data is inserted or deleted. Just in the previous slide, I told you insertion and deletion operation is little bit difficult with the help of array, because to insert or delete the element from the array we need a data movement. ओके, आपल्याला कधी इन्सर्शन डिलीशन ऑपरेशन करायचं असेल array मध्ये, तर थोडं डिफिकल्ट टास्क आहे. वाय? बिकॉज वी हॅव टू परफॉर्म द डेटा मुवमेंट. आपल्याला डेटा शिफ्ट करावा लागेल. इफ यू वॉन्ट टू डिलीट फिफ्थ एलिमेंट और फोर्थ एलिमेंट, देन यू हॅव टू मूव फ्रॉम 0 to 3. Then only you will reach to the 4th index. So this is not an efficient task. Hence, array is inefficient for application which very often need insert and delete operation in between. Okay, main limitation or drawback of array is that wherever you require insertion or deletion operation in between the array, wherever you require insertion or deletion operation in between, then array is not efficient. जिथे आपल्याला कोणत्याही एलिमेंट, कोणत्याही लिस्ट मधला किंवा array मधला एलिमेंट मधला मीन्स नॉट मिडल, इन बिटवीन फ्रॉम स्टार्ट टू एंड, याच्यामधला कोणताही एलिमेंट डिलीट किंवा इन्सर्ट करायचा असेल, याच्यासाठी आपण array वापरू शकत नाही, बिकॉज इट इज नॉट इफिशियंट. ओके, सो दीज आर द ड्रॉबॅक ऑफ array. Now applications of array. Applications of array means where we can use the concept of array. So Array the data structure, okay, to store the sequential operation, to perform the sequential operation, we need of array. And in unit number 1, we have studied data structure, stack and queue. Am I audible? आवाज येतोय माझा?
Yes, sir.
Yes,
Okay,
sir.
okay, fine. Okay, so to implement any stack operation, queue operation, tree operation, we can, sorry, not tree, stack and queue operation, we can use the array. Even to perform, to perform, uh, to perform the linked list operation, we can use the, no, to perform the stack and queue operation, we can use the array operation. Also, there are two types of array, 1D and 2D. To implement the matrix program, we need of 2D array. मॅट्रिक्सची काही कोडिंग करायची असेल त्याच्यासाठी आपल्याला कसली गरज आहे? array. पण कोणता array? 2 dimensional array. Okay. To perform any graphics operation, 3D operation, we need of 3D array. So these are the applications of the array. I read the slide. Although useful in their own right, array also form the basic several more complex data structures such as heap, hash table. Just in the previous slide we have seen, in the heap or hash table we can use the array. To represent string we can use array, stack, queue, we can use array, stack and queue. We have separate unit for stack and queue. So don't worry about that. I will explain the stack and queue in detail in unit number 3 and 4. All the application benefit from compactness and direct access benefit of array. Okay, where you want to perform the direct access or random access, at that time we can use the array. Application लक्षात ठेवा. जिथे आपल्याला डायरेक्ट व्हॅल्यू ऍक्सेस करायची असेल किंवा मॅपिंग करायची असेल तिथे आपण array वापरू शकतो. 2-dimensional data when represented as a matrix or matrix operation. ओके, अजून कुठे वापरता येतो array? मॅट्रिक्स ऑपरेशन करण्यासाठी. कोणता array वापरतात त्याच्यासाठी? 2D array, 2-dimensional data when represented matrix. I will show you example of matrix, how to represent matrix. Okay, one more example which is not mentioned on the slide, to represent a polynomial we need of array. पॉलिनॉमियल पण दाखवण्यासाठी आपण arrayचा वापर करतो. We can use array to represent polynomial. Okay, next concept. Next topic is that concept of order list. Order list, as the name suggested, order means again same, sequential or same type of data. Order list is the most common and frequently used data object. Linear elements of an ordered list are related with each other in particular order or sequence. Okay, these are the example 1, 3, 5, 7, 9, 11. Now you can understand this. These are the odd number list. Okay, means this is the odd order. January, February, March, April. Okay, month. These are again order list. Same type of element. Red, blue, green, black, yellow. Okay, means name of color, but same of but same type of data are mentioned in the order list. You cannot store 1 January red. Okay, we don't use order list for that. In order list we can store the similar kind of data, either number or month or color. Okay, or name. There are many basic operations that can be performed in order list. In order list, we can find the length of the list. We can traverse the list from left to right. You can note down the point. Operations of order list. Basic operation of order list. First one, we can find the length of list. Second, traverse list from left to right or from right to left. We can traverse from left to right or right to left. Access the ith element in the list. Ith element means we can access or we can use any element from the list. For example, if suppose Whenever if suppose red, blue, green, black, yellow. Okay. So if you want to access the green color, okay, then you can directly access the green color with ith element. Assign the array 0, 1 and 2. Okay, index is 2 index assigned to the green, means with the help of 2 index you can access the green color. So access ith element, update the value of the ith position. Okay, we have already studied this in array. We can overwrite or update the value of the specific location. If suppose you want to update the value of a of 4, fourth location, then variable name a of 4 is equal to 10. Then 10 value will be replaced to the a of 4 memory location. Insert an element at ith position, delete an element at ith position. Insertion and deletion we can perform in the ordered list. Okay, we have completed two topics. Concept of array, that is the advantage, disadvantage, applications. Now second one is the order list, and now third topic, that is the single variable polynomial. Okay, you may be familiar with the polynomial. Okay, in mathematics you may have studied the polynomial or quadratic equation. Okay, so single variable polynomial, but we have to represent the polynomial with the help of the array. So note, you can note down the definition single variable polynomial. Polynomial denote as a p of x. Polynomial denote as a p of x is the expression in variable x, is the expression in variable x which is in the form ax raised to n plus bx raised to n minus 1 plus cx raised to n minus 2 and so on. Okay, so note down the definition. Polynomial p of x is the expression in variable x. Expression in the variable x, which is in the form. Value of the x will be ax raised to n plus bx raised to n minus 1 plus cx raised to n minus 2 and so on. Where ABC means where a, b and so on, a, b, c and up to k. Okay, we say coefficient. In polynomial we say coefficient, and this is the exponent. A, B, J, K are the coefficient, and n minus 1, n minus 2 are the exponent. So A, B, C, K fall in the category of real number. It should be a real number, either minus 1, minus 2, 1, 2, 3, 4, whatever. It should be real number. What? A, B, C, K, whatever. Okay, and n means x raised to n. Okay, exponential part. N is a non-negative integer. N is a non-negative. N should be non-negative integer. Either means 0, 1, 2, 3, 4, and which is called as the degree of polynomial. ही डेफिनेशन पाठ करू नका. ओके, पाठ करू नका डेफिनेशन. लक्षात ठेवा, पॉलिनॉमियल डिनोट बाय p of x. Okay, p of x, it is the expression in variable x. Okay, x can be the x is in the form ax raised to n plus bx raised to n minus 1 plus cx raised to n minus 2 and so on. Okay, where डेफिनेशन कशी लक्षात ठेवा, फक्त याच्यावरून लक्षात ठेवा. p of x is a polynomial. Okay, it is the expression in variable x which is in the form, कोणत्या फॉर्म मध्ये असते, ax raised to n plus bx raised to n minus 1 so on. Where इथपर्यंत डेफिनेशन झाली. where a, b, c, d, e up to k हे काय आहे, याला कोएफिशिएंट पण म्हणतात. फॉल इन द कॅटेगरी ऑफ रियल नंबर. हे काय पाहिजे, इट शुड बी रियल नंबर. रियल नंबर मीन्स minus 1 पण असू शकतो, minus 2 ही असू शकतो, 1, 2, 3, 4, 5 whatever. Okay, but these are the coefficient and exponent part. n minus 1, n should be non-negative integer. N should be non-negative integer. Non-negative means 0, 1, 2, 3, 4, 5 पण तो निगेटिव्ह नसायला पाहिजे. लक्षात आली डेफिनेशन? पुन्हा रिपीट करतो. अ पॉलिनॉमियल डिनोट्स बाय p of x. It is expression in variable x which is represented as ax raised to n plus bx raised to n minus 1 plus cx raised to n minus 2 and so on, where coefficient and exponent, these are the base part is the coefficient and raised to exponential raised to part is the exponent. So a b coefficient should be real number. It can be negative number, but raised to, but value of n minus 1 exponential value should be non-negative integer. It should not be a negative integer. So this is a basic definition. Okay, there are two parts. One is the coefficient, another is the exponent. Just I told you, a b are the coefficient. A is the coefficient, n is the exponent. B is the coefficient, n minus 1 is the exponent. Okay, so here you can see the example. 10x square plus 26x. 10x square plus 26x. Now you can understand 10 and 26 are the coefficient. 10 and 26 are the coefficient. 2 x raised to, here nothing but there is the coefficient associated with some value, means exponent value is the 1. Okay, so that's why 10 and 26 are the coefficient and 2 and 1 are the exponential value. लक्षात आलं असेल तुम्हाला सिंगल व्हेरिएबल पॉलिनॉमियल कशाला म्हणतात. ओके, सिंगल व्हेरिएबल पॉलिनॉमियल representation using array of structure, polynomial evaluation, polynomial addition, multiplication of two polynomials. Okay, these are the single variable polynomial. No, you can note down the point. Representation using array of structure, polynomial evaluation, polynomial addition, and multiplication of two polynomials. Okay, these are the operations. Type of operation है, we can represent polynomial using array. Okay, you can evaluate the polynomial. You means calculate the polynomial. You can perform the addition between two polynomials. You can perform the multiplication between two polynomials. आवाज येतोय माझा?
Yes, sir.
Okay. One minute. Okay, next topic, polynomial representation using array. Now here you can see 5x raised to 4 minus 10x raised to 3 plus 3x raised to 2 plus 10x minus 1. Now here you can understand 5 10 3 10 5 minus 10 3 10 minus 1 are the coefficient. हे काय आहे? कोइफिशियंट आहे. आणि एक्सपोनंट काय आहे? 4 3 2 1 0. 4 3 2 1 and 0 are the exponent. So I will show you how to represent a polynomial. I don't read theory. I will PPT is also available on my blog. You can read the PPT. I just explain you concept of the polynomial representation. Okay. Now here you can see how to represent polynomial array. Okay, it is divided into two fields, exponent and coefficient. Okay, so in array we assign the index. So assign the index from 0 to n number. Okay, 6. Now here you can see. Okay, for index 0, what is the coefficient? Minus 1. Okay, raised to 1. Okay, for exponent 1, what is the value? Coefficient plus 10. Okay, here you can see 2. 2 means exponent. Okay, so come here. Okay, 2 is the exponent. Okay, 2 exponent. What is the coefficient for exponent 2? 3. So here 3. Okay, come here. Okay, exponent is 3. Okay, 3. What is the value associated with exponent 3? Minus 10. Okay, minus 10. That is the real integer. Minus 10. So, minus 10. Come here. 4. 4 is the exponent. For 4 exponent, what is the value associated? 5. So, 5. So, in this manner, you can represent a single variable polynomial with help of array. This is the array. Okay. We have assigned index as the exponent. We have assigned index as a exponent. जसं आपण array मध्ये करतो ना a of 10, 0 to 9, तसं आपण इथे सेम केलंय 0 to 9, 0 to 6 आणि त्याला काय केलं एक्सपोनंट. एक्सपोनंट मीन्स कोणता पार्ट 4, 3, 2, 1. इथे काही नसतं पण इथे 1 असतो. ओके, माहित असेल तुम्हाला मॅथमॅटिक्स 1. ओके, हिअर ओनली कोएफिशिएंट. ओके, सो what is the exponent? 0. So for 0 exponent value is -1. For 1 exponent value is 10. For 2 exponent value is 3. For 3 exponent value is -10. Minus लिहिण्याचं नका विसरतो. -10 and 5. So this is a basic example to represent the polynomial. Polynomial as an additive. जसं आपण array मध्ये बघितलं होतं ना array as an additive, तसं polynomial as an additive. Basic operation of polynomial. Creation of polynomial, addition of two polynomial, subtraction of two polynomial, multiplication of two polynomial, and evaluation of polynomial. You can note down the point. ADT for polynomial, abstract data type. ADT for polynomial or basic operation of polynomial. कोणकोणते ऑपरेशन असतात? फर्स्ट, creation of polynomial, addition of polynomial, two polynomial, subtraction of two polynomial, multiplication of two polynomial, and evaluation of polynomial. Evaluation means calculation. If suppose, for example, 1 plus 2 plus 3. Okay, 1 plus 2, 3. 3 plus 3, 6. This is the evaluation of number. So same polynomial evaluation means we can evaluate the polynomial. Here you can see two examples for polynomial using array. Here you can see two examples. Polynomial is given 3x cube plus x square minus 2x plus 5. Now here you can see what is the exponent for 5? 0. What is the exponent for 2x? 1. What is the exponent for x? 2. What is the exponent for 3x? That is a 3. Okay. So here array assigned 0 to n minus 1. So here you can see for you can traverse from left to right or right to left. Okay. So in that you can see they are traversing from left to right. So in that you can see for first coefficient, that is a 3. Okay. Actually that is 3 or not, I'm not getting. I think it is 4. It may be 4. Okay, fine. Okay, coefficient value stored here 3, then x, there is the value 1. Okay, and for 2, for second index value is the -2. Simply assign the index, and as per the traversing from left to right or right to left, just assign the coefficient. Coefficient 3, 1, -2, 5. Okay, so value is 5. So there is you can write 5 also. Here you can write 5 also because there is the 5 value given. Okay, another example. Here you can see value are not clearly visible, I can understand, but just try to understand the problem. 11x raised to 8, 11x raised to 8 plus 5x raised to 6. Now here you can understand 8 and 6, but 7 is missing. If suppose any exponent is missing, then you can put value 0. तुम्ही इथे पाहू शकता 11x रेस टू काय आहे 8 8 आणि ते 5x रेस टू काय आहे 6, पण 7 दिलाय का नाही. अशा वेळेस ॲरे मध्ये बाय डिफॉल्ट इफ exponent value is missing, then automatically array initialized to 0. Okay, so again 0 to 8 index. Okay. First one, what is the coefficient? 11. Now here you can see 11. Okay, 8 and 6, 7 is missing, 7 nahi hai, so 7 is missing, so that's why 0. Now here exponent 6, coefficient 5. After 6, here you can see 5. Okay, x means coefficient is 1. 2x raised to 4, x raised to 4, coefficient is 2. But here you can see x raised to 4, 3x raised to 2. Again exponent 3 is missing. इथे दिसत असेल तुम्हाला exponent 3 नाही दिलेला आहे, तर आपण त्याच्यात काय घेऊ 0. So here 5 initialized to 0. Again 2 coefficient is -3. Here x is a 1, and here you can directly put the value 10. Okay, that I want to show here. Here value is 5, but they have put 0. Okay, so this is a mistake. Here you can directly put 5 like this. Okay, these are the examples to represent the polynomial using the array. Okay, one more example. X raised to 99 plus 78. X raised to 99. It means we have to initialize the array from 0 to 99. Okay, we have to initialize the array from 0 to 99. So here initialize array 0 to 99. Okay, so here x raised to 99 means just we put 1 as a coefficient, because only single value for x value, so we can insert 1, but there is no 98, 97. Okay, all value are missing, so we can put 0 to all value, but after 0 index we will get 78 value, so we at the 99 index we can put value 78. Okay, in this subject you have to write theory with the help of example or syntax, so that's why I am explaining you more example. Which structure is better than array for polynomial? Structure is better than array for polynomial. I have not taught you structure. It is a programming concept, but in structure you have to maintain the structure. You have to assign the whole memory to structure. With the help of the object we have to maintain the structure. So that's why structure is better than array for the polynomial, because in array we don't use the object. But in this unit we are going to study about the array, so no need to know more about the structure. We are going to use array for the polynomial. Okay, more example I have taken, so I skip that part. What's the time? 3:13. Okay, last part of today's session, that is the sparse matrix. Okay, we have completed array, we have completed order list, we have completed single variable polynomial. Okay, but in single variable polynomial operations are we have not seen operations of polynomial. So in the next session I will continue with the operation of the polynomial. Okay, now next part is the sparse matrix. Okay, it is one of the type of the matrix, sparse matrix, a matrix number of which contain the number of zero entry. Okay, but it is not necessary to it is not necessary to make a matrix with all zero value. There can be a maximum number of zero present in the matrix. Then we can say that matrix is called as a sparse matrix. 2D array is used to represent a sparse matrix in which there are three rows named as, okay, just I told you array. We can display the we can represent matrix operation with the help of the array, but we can use the 2D array. Okay, and we know in 2D array they they associate with the row and column. Okay, so here you can read row index of row where non-zero element is located, and column index of the column where non-zero element is located. Non-zero element can be located in the matrix. I will explain you about the sparse matrix. Okay, here you can see the example. A sparse matrix is a matrix which consists number of consist most of zero entry. Okay, so here you can see the matrix with the 4 row and 5 column. Matrix with 1, 2, 3, 4 row and 5 column. Okay, now here you can see. Now here you can see there are number of zero entry in this matrix. तुम्ही पाहू शकता बघा इथे नंबर ऑफ झिरो एंट्री खूप आहे याच्यामध्ये, है ना. त्याच्यामुळे अशा मॅट्रिक्सला काय म्हणतात, स्पार्स मॅट्रिक्स. ओके, नोट डाउन द डेफिनेशन. स्पार्स मॅट्रिक्स is a matrix in which there can be most number of zero entry. Sparse matrix is a matrix which consists of most number of zero entry. स्पार्स मॅट्रिक्स म्हणजे अशी मॅट्रिक्स ज्याच्यामध्ये नंबर ऑफ झिरो एलिमेंट एंट्री जास्त असतात. नाउ हियर यू कॅन सी, ओके, अँड नॉन झिरो एलिमेंट आर 3, 4, 5, 7. ओके, नाउ हाउ टू रिप्रेझेंट स्पार्स मॅट्रिक्स युजिंग 2D array. याला कसं रिप्रेझेंट करतात. सो नाउ यू कॅन सी रो नंबर 0, रो नंबर 1, रो नंबर 2, रो नंबर 3. Okay, column number 0, column number 1, column number 2, column number 3, column number 4. Okay, there are 0 to 4 column and 0 to 3 row. Now here you can see 0 number of row and 2 number of column. 0 number of row and 2 number of column. It consists value 3, है ना. 0 नंबरची रो आणि 2 नंबरचा कॉलम. इथे कधी गेलो आपण तर काय मिळते आपल्याला व्हॅल्यू नॉन झिरो एंट्री 3. सो दॅट्स वाय 0 रो अँड सेकंड कॉलम व्हॅल्यू इज 3. सेम जस्ट टू फाइंड नॉन झिरो एंट्री. स्पार्स मॅट्रिक्स मध्ये फक्त आपण अशा एंट्री फाइंड आउट करतो नॉन झिरो एंट्री जे की झिरो नाही आहे. ओके, अजून कुठे 4 झिरो नंबरची रो आणि 4 नंबर कॉलम. 0 नंबर रो अँड 4 नंबर कॉलम. 0 नंबर रो 4 नंबर कॉलम व्हॅल्यू इज 4. सेम 5 किती नंबरचा कॉलम आहे, किती नंबरची रो आहे 1, कॉलम 2. ओके, 1 अँड कॉलम नंबर 2, 1 कॉलम नंबर 2, 5. सेम 7 कॉलम नंबर रो नंबर 1, कॉलम नंबर 3, रो नंबर 1, कॉलम नंबर 3 अँड व्हॅल्यू इज 7. ओके, अजून कुठे व्हॅल्यू नॉन झिरो, इथे 2. ओके, 3 number row and 1 number column. 3 number row and 1 number column. 3 number row, 1 number column, value is 2. Same. 6. 3 number row, 2 number column. 3 number row, 2 number column, value is 6. This is a basic simple representation of sparse matrix using 2D array. याला म्हणतात matrix representation using array with the help of row and column, and we cannot represent any matrix without help of 2D array. 2D array वापरल्याशिवाय आपण मॅट्रिक्स ऑपरेशन परफॉर्म रिप्रेझेंट करू शकत नाही किंवा कोडिंग मध्ये पण परफॉर्म करू शकत नाही. आवाज येतोय?
हो सर.
ओके. Okay. Now you can see last topic for today's session, sparse matrix. Okay, rest of the part I will continue with the next session. Here you can see 1, 2, 3, 4, 5, 6, 7. How many rows? 7 rows and 1, 2, 3, 4, 5, 6, 7. 6, 1, 2, 3. Okay, 7 rows and 5 columns. In that you can see 7 rows and 5 columns. Okay, so in that if you want to represent array, if you want to represent the matrix with the help of the array, then you can one number of row and one number of column, one number of row, one number of column. Okay, then the value is 1. So here you can see, you can write one number of row, one number of column, and non-zero entry is 1. 9. 2 number of column and 2 number of row. Value is 9. 2, 2, 9. Now you can see. तुम्ही बघा याच्यावरून, या एक्झाम्पल वरून तुम्हाला हे कळतंय का? लक्षात आलं असेल बघा तुमच्या. फक्त काय करतात, जी नॉन झिरो एंट्री असते ना ती घेतात आणि त्याचा रो अँड कॉलम नंबर फक्त फाइंड आउट करायचा. रो अँड कॉलम मीन्स दिस इज अ टू डायमेन्शनल ॲरे. रो आय अँड कॉलम इज जे. So value a of ij is 1. A of ij its value is 9. लक्षात आलं असेल तुमच्या स्टुडंट्स? लक्षात येतोय का एक्झाम्पल? प्लीज रिप्लाय. या सब्जेक्ट मध्ये ना थेरी खूप कमी आहे. तुम्ही बघत असाल स्लाइडवर थेरी खूप कमी आहे. डेटा स्ट्रक्चर सब्जेक्ट मध्ये फक्त डेफिनेशन लिहायची असते आणि ऑलमोस्ट थेरी कशावरून लिहायची असते? एक्झाम्पल वरून किंवा कोडिंग पार्ट. त्याच्यामुळे याच्यात थेरी नाही लिहित. हा पाठ करण्यासारखा सब्जेक्ट नाहीये. हे एक्झाम्पल कळायला ना, याच एक्झाम्पलला आपण थेरॉटिकल लिहू शकतो. कसं लिहू शकतो आता हे बघा. फॉर एक्झाम्पल, ओके, दिस इज अ स्पार्स मॅट्रिक्स. ओके, डेफिनेशन ऑफ स्पार्स मॅट्रिक्स इज दॅट इट कंटेन्स द नंबर ऑफ zero entry in the sparse matrix. A sparse matrix can be solved with the help of the two-dimensional array. मी काही न बघता स्वतः थेरी बनवतो, तसं तुम्ही पेपर लिहिताना बनवतात बघा, तेच मी तुम्हाला सांगतोय. ओके, a matrix contains 7 number of row and 5 column. Matrix contains 7 number of row and 5 column. एक अजून पॉइंट झाला, अजून पॉइंट सांगतो. This matrix contains number of zero entry. एक अजून पॉइंट झाला, अजून एक पॉइंट सांगतो. 1, 2, 3, 4, 5, 6, 7, 8. Okay, in this matrix there are 8 non-zero entry. In this matrix there are 8 non-zero entry, and representation of matrix as shown in the table. बस झाले थेरॉटिकल पॉइंट. याच्यामध्ये थेरी मनाने बनवायची असते, लॉजिकली, पण प्रॉब्लेम खूप इम्पॉर्टंट आहे. ओके, लक्षात आलं?
हो सर.
Okay, so in the next session I will continue with the transpose of sparse matrix. So this is enough for today.